Good morning again. After the working with the Michael ladder, we will now have the first keynote contribution of this conference. The title is From the Individual to Society, a Holistic Perspective on Climate Change. And the two speakers are Lin Bautze and Adrian Müller. The two are scientists and they work together for a big IFOAM study. And actually, Lin Bautze is working in the section of agriculture at the Goetheanum, and her flagship project is called Living Farms. And she will bring from this research to our awareness today what she can take out under the title of this keynote contribution. And Adrian Müller is researching at the FiBL, the Organic Research Institute in Switzerland, and he is co-author of the big study, Can Organic Feed the World? And you hear already that with this contribution, we go to the crossing field, let's say, of what we have as a research based on agronomical terms, now to societal research. And this is what it is about, and we are looking forward to your contribution. Thank you being here, and it's up to you actually to give your contribution. Thank you.
So we are here today to talk about climate change with a particular focus on agriculture. Climate change is complex, it's challenging, and it's serious at the same time. The facts and figures show us that this theme decides upon our society and nature's further development. As I'm fascinated with global challenges and how we can overcome this as one society, this theme attracted my professional and personal attention around 13 years ago. For 13 years, I can witness how research developed, how politics ignored or reacted to the research findings, and how the perspective of our society changed within the last years. All of this while the global temperatures rose constantly and continuously during this time, and while the pressure increased for the farming systems, for our forests, for our health system and infrastructures. We all know that we live in a globalized world. We are connected via our atmospheres, our climate, our soils, and our society. Throughout the last years, we did a great deal of destroying the same resources that we depend on. We have depleted our agriculture. Okay, sorry. We have depleted our resources, our agricultural soils. We threatened our biodiversity. We polluted our water bodies and our atmosphere at the same time. Here we can see that normally we exceed our resources available for the whole year already in the summer season. And now in this pandemic, I think more than ever, we realize that we are intertwined with the nature and with one another, and that the separation between nature and our human society is not a solution anymore. This holistic thinking may challenge us. It may challenge our perspectives and ask us to take a joint responsibility in a very fast time. This perspective is away from the sole individualistic thinking towards a collaborative approach. It asks us to act individually out of our free wills but to think and to feel globally at the same time. To really include not just ourselves, but the whole world around us into our individual thoughts and actions. Today, we will present how this kind of holistic thinking may be developed and initialized for the agriculture sector. Currently, we are having a system where the emissions for the agriculture system are counted in a way that does not represent the whole society's picture. The majority of the emissions that are accounted for derive from the soil and animal husbandry. But however, this is not just the direct emissions, but further emissions and indirect emissions derive from the agriculture and the food systems. So at this time, I will hand over to my colleague Adrian to show you further details of the exact figures.
Thank you. Yeah, and I will, in the following minutes, present sort of a tour from detailed reductionist data, which is always important, and also linking it to this holistic view, also to societal discussions and so on. But I will start with the individual data. Oops. It's not showing what we would have liked it to show. But I can do it. Can I blacken it? Well, let's keep the black one. So
Sorry.
Imagine what you will see on this graph. Can I have a black one? Well. So what I wanted to show is the emissions from agriculture. They are mainly from the fertilized soils. You already said it. And from the animals, from the enteric fermentation of the ruminants. This is, when we look at the agricultural level, where the emissions mainly come from, and important there is to note that it doesn't matter which fertilizer we put on the soils, be it mineral fertilizers, be it manure, be it compost, all the nitrogen we put on the soils leads to emissions, basically. And as long as we have animals, and especially ruminants, we have these emissions from the enteric fermentation. And I want to emphasize this because it's important to see this on a global level in relation to the emissions from fertilizer production, which is almost an order of magnitude less important on a global level, and to emissions from machinery, which is also not so important on the farm. And then we have also emissions from rice production, biomass burning, which is in many countries still quite important, and manure management. And then when you have these emissions, then you have a big chunk of emissions from deforestation, from land use change, which is almost as big as the whole emissions from agriculture. And you have the reductions possible from soil carbon sequestration, which is on a similar level. I will come to that later. So this is the picture of emissions. Fertilized soils, enteric fermentations from ruminants, and land use change are the big things. And what this links to is, can I now have the presentation again? So we take the next one and see what happens. This links us to what we can do. So we can reduce, on the agricultural field, globally speaking, or aggregately speaking, we can reduce fertilizer input. And this illustrates the problem we have over the last decades. We have a huge increase in mineral fertilizer input, which is one basis behind emissions from agriculture. We have the animals, especially the ruminants. With the enteric fermentation, we can work on to reduce the number of animals. And there, the idea, and now it starts becoming a little bit more systemic, is that ruminants can eat grass, but they shouldn't eat soybeans and crops from areas we could directly use as food. And the third thing is, oops, a question mark. And the question mark is soil carbon, which links to soil fertility, to this focus on the soils in organic and biodynamic agriculture, and where we have a big potential, which is often also overestimated though. And the last question mark, maybe it's good that it is a question mark, because this would be the idea of circularity in our agriculture and food systems, that if we want to work on reducing emissions from agriculture, we have to take a food systems perspective, as you already mentioned it as well, and we have to see how we produce. And if we look at the ruminants, for example, the ruminants have a role to play in our food systems by converting resources we cannot use for food production to food, but they shouldn't, as I already said, eat concentrate feed. And if we adopt such a view, which is linked to a circular view of the food system, where we use the resources for the best aims we can use them for, and where we recycle all the nutrients possible. So we use residues and byproducts and waste products to feed animals, and then we recycle the manure back to the fields and so on. Then we have a food system which can be quite climate friendly. Here the graphs come, but now we run through them, otherwise it gets too late. And here, this is a first a table, what is the potential of these mitigation actions in agriculture. This is from the study for iFoam, and I only want to highlight two things. This is for Europe, and we have quite a big potential for like emission reductions. These are this number that we can reach on average over the years from organic soil carbon sequestration. And in Europe, because it's so intensive, quite a lot from mineral fertilizer use reduction. And we also have this from the general nitrogen use emission reductions. And what we can achieve in such an intensive system with sort of such basic measures is, on average, up to 2060 maybe per year, we have something like 20% in the end. This is increasing with soil carbon sequestration, and then it goes down again, because soil carbon sequestration cannot be done indefinitely. But there is a potential, especially in intensive systems. If you look at it globally, this is from a global study where we reduced the use of concentrate feed basically to zero. So we fed the ruminants only on grassland. We fed the monogastric animals, the pigs and the chicken, only on waste streams, on byproducts, not used for human consumption. And in such a system, we achieve a greenhouse gas emission reduction of about 20% compared to 2050. This is today, this is 2050, business as usual. This would be this system we modeled. So we have, with such a systemic view, what are the animals for in the food system, we have a decent potential for reduction as well. And I emphasize models. These are sort of quantitative visions. These are not realities. So these are quantified a basis for discussion on how the future may look like, what could be viable, what not, where trade-offs and synergies may arise. And the last point I want to emphasize here is soil carbon sequestration, because this is always important in the discussion on climate change mitigation, especially in organic agriculture and biodynamic agriculture. Soil carbon sequestration always has a dynamic of a saturation. So we have sort of a basic natural system level of soil carbon, then you till it conventionally and you lose the soil carbon, then you can do better management and build up the soil carbon again, but this doesn't go on indefinitely. So there will be a good level, a healthy soil again, but you cannot just go on with this. So you will reach a really sustainable, healthy system again, but it will stop sequestering carbon at a certain point of time. And this is important to not exaggerate what can be taken from soil carbon sequestration. And the second thing is, this is all the data we have on soil carbon sequestration in organic agriculture, that if you look all the data, we can have almost 0.5 ton of carbon per hectare sequestered per year. But these are systems sometimes that import biomass from outside. And if you look at only the systems that are really closed, that do not import biomass from outside and do not mine soils outside their system boundaries, the sequestration rate is not that big. It's just not significant anymore. So these are not really many data anymore, but it's important to highlight that we need to really go beyond this plot level. Soil carbon sequestration per hectare can only be assessed if we know within which system boundaries this is done. And this links back to the circular approach. We shouldn't sort of export impacts beyond the system boundaries we are interested in. And this is an illustration of this in the soil carbon sequestration debate. Are we looking at closed systems, or are we importing lots of biomass to build up soil carbon in a certain area and lose it in another area? There are contexts where this makes sense if you have lots of biomass from, for example, urban areas which you cannot use elsewhere, but there are also examples where it doesn't make sense. So now I want to take a little bit a more systemic view, again from another angle, regarding how we measure our climate performance. And you may all know this, oops, that's the wrong, yeah. But you may know all these footprint metrics. What are the greenhouse gas emissions per kilogram product? And then you always see the animal products are up here with high emissions per kilogram products, the plant-based are down, and the ruminant meat is always worst. And this is the reductionist view. This is correct, but it's not what interests us. And if you look at it systemically, this is now not the life cycle analysis of ruminant meat or chicken meat or nuts, but this is a calculation for the whole global food system, where we have a baseline, that's the red line, 2050 again, where we have a conventional system, that's the blue one, with 50% less waste. This is another big lever we have for climate change mitigation, and 100% less concentrate feed, what I talked about earlier. So it reduces basically all impacts we have, also the greenhouse gas emissions. And then we have the yellow system, which is the same as the blue one, but organic. So we get basically rid of the mineral fertilizers, have some lower yields, some change in crop rotations. And we see the greenhouse gas emissions are on the same level. So we can have organic systems. We can have organic systems that achieve considerably lower greenhouse gas emissions than the business as usual. Not necessarily lower than conventional. I will come to this relation later again. But on a total level, it can be done. And importantly here is we have quite a lot of ruminants in the system still compared to monogastrics, because they are used to utilize the grasslands we have. We have almost 70% of all agricultural areas grasslands globally. And this is in contrast to this bad performance of ruminant meat. And this is important, that here we have a sufficiency view, what is the total emissions, and that is what counts in the end. And on the left we have an efficiency view, what are the emissions per kg product. But if you produce too much, this doesn't really help, because you can be really efficient per kg product, but you have too much production, so it's still in total a too high emission. And that's what we look at here. We are not really efficient per kg product, but in total, it's on all the impact levels we have a decently optimized system. And that's sort of also the key behind climate change mitigation in agriculture and food systems. We have to make the system smaller. And that's where the wastage comes in. If we reduce food waste, That's the easiest way to reduce emissions, because what is not produced doesn't cause any emissions. And the second thing is we have to get rid of the high level of animal source food we have, boosted by concentrate feed. This is regionally very diversified. There are many regions where it would be good to have somewhat more animal production. And I don't talk about ethical issues now of animal rights, animal welfare and these aspects, but merely from an agronomic perspective. But we have many regions where we have too much animal source food. This then also links to a scale debate, and this also links back to what I said on the system boundaries for soil, organic carbon. On which level do we address climate change mitigation? Is it plot level? Is it a farm level? Is it a landscape level? Is it a national level? Or is it a global level? And it makes a big difference what can be done if you try, for example, to be climate efficient on plot level, on farm level, or if you try to do it especially on landscape level. And I usually opt to have a landscape view, because this gives lots of flexibility that certain farms may perform well on one aspect, less well on another, but in total on a landscape level they perform well and they can close the nutrient cycles and so on. And the landscape level also fits to the other impacts we have from agriculture, like on the ecosystems with nutrient surplus and so on, pesticide runoff, whatever, because the landscape level usually fits well to the important ecosystem boundaries we have. And that's why we should have a focus there on a landscape level rather than a farm or even a plot level. And what comes in here is that if you look at this, you can sort of trade off. So one can be better on one hand and worse on another, and another one can be the reverse side. And this then links to things like greenhouse gas emission trading and such stuff, because for greenhouse gases, basically the global level is relevant. We have just to reduce the global greenhouse gas emissions. And there it's important to be aware of such things from a physical point of view, biophysical point of view. It's sort of okay to reduce emissions elsewhere, and the system boundaries may be really global, but from a societal, ethical point of view, it may be not, but one has to separate these discussions. And I think it's important to really clarify what are the arguments for a certain system boundary. Is it sort of a biophysical one, or is it also because of due to values, due to ethical decisions we have? And the final thing I want to emphasize, because climate change mitigation often dominates, but in agriculture I think climate change adaptation is much more important. And this is a table from a study we are in the course of publishing on whatever we know on the adaptation performance of a different range of agroecological, let's say, practices, characteristics, and so on. And it's quite complex, but what I want to emphasize is that we quite strongly see that all systems like agroforestry, cover crop, or organic agriculture and so on, they support soil health, soil fertility. They support diversity, but they have a little bit of a drawback on the productivity. That's sort of the yield gap we often see. But if we have to produce less because we do not have the waste and we do have less animals in the system, then this yield gap is not such an issue. That's also what we saw in our calculations for the feeding the world with organic agriculture. And maybe here a short side remark. What we see is that diverse systems that focus on diversity, they tend to be quite productive and stable in yields, but there are indications that the current organic agriculture as we do it is not so stable in yields as conventional and doesn't have so high yields. So I would, for example, from this maybe derive, one would have to look at it in more detail, but the hint that we should really build more on the diversity in our systems, also in the organic systems, that we really harvest the potential of diversity in the agricultural production systems, which is not yet done to that extent it could be done, I think. Now I come to 3 challenges with these systems, or with these approaches of climate change mitigation based on a systemic level where we have less waste, less animal source food. The first challenge is diets. Clearly, in such a system, we have way less meat and milk and eggs in our diets. It will drop from about 40% to about 10% in these simulations, in these visions we have. And importantly, the monogastric meat will drop by like 90%, and the ruminant meat and milk maybe by 50%. So it's really a drastic shift in how our diets have to look, that such systems become viable. And that's also why we cannot talk about mitigation of climate change in agriculture without talking about the food system and the consumption side. The second thing is nitrogen use or nitrogen availability. If we get rid of mineral fertilizers, we basically have to produce the fertilizer and the product on the same areas, or we need areas to get our fertilizers, basically. So we get new fertilizer into the system only by biological nitrogen fixation or by importing biomass from outside the system boundaries. But if we look at it in a circular way, so with closed nutrient cycles, it's really a challenge to have enough nutrients in the system. And in our global modeling, we see the organic, that's again the yellow one, performs well on many of these impact categories like greenhouse gas emissions, but the nitrogen runs into a deficit. So if we really have a large scale, now here it's organic system, we have to focus on getting these nitrogen cycles really closed, on having enough nitrogen in the system. And I think that's a challenge. It's not doable. The lack is not huge or so, but it's something one really has to keep in mind when going for large-scale organic agriculture. And the last one is plant protection, where there is a hypothesis that current organic systems perform well because they are embedded. These are sort of the green ones. They're embedded in a conventional context that does all the plant protection for the organic ones. This is something we should closer look at, whether this really is so or not. There are signals that it is that go in this direction, signals that do not go in this direction, that say the opposite. But there are critics of organic and agroecological approaches that say if we expand it, we will have an unexpected problem of plant protection because there is a lack of this conventional overarching plant protection context. And this is just to highlight potential challenges that may arise. I don't say this will be a problem, but I guess there is quite some research needed or some trials needed in large-scale implementation, which we see more and more, whether this really works, what are the challenges. Just shortly, 2 additional challenges. We definitely need big efforts in education, farmer formation, all this, and also research, money and so on. This is still way too less that goes into agroecological approaches. So it should be much more mainstream that we have the potential that agroecological, organic, biodynamic approaches have, that they are named and discussed in the education programs and so on, the farm schools and so on. So I come to some chances, not to end only with challenges, which is linked back again to the farm or landscape level, because what I want to emphasize there is that it gives us lots of flexibility. If we want to perform well on a landscape level or as a community, this means that not every farm, not every individual has to perform optimal on all aspects. There is some flexibility that some farm has lots of animals with lots of emissions. Another farm takes all the manure and uses it on the fields, and in total it's quite a nice system. And also in a community or as individuals, some people may eat quite a lot of meat, others are vegan. So if it's not an unjust solution, I think this a little bit larger picture than the individual performance gives us lots of flexibility to achieve our goals. And so I will have some final words. And the first one is how do we start this needed fundamental transformation? We saw this drastic dietary change, how we get societies to accept this and so on. I have no answer, but that's what we are here for, to discuss this, to be inspired, to find answers. The second thing is it's linked. What is a good life? Is a good life one where I want to eat meat or not? And what is linked to this? And there it's important, to, in my view, to be quite, or my part is quite liberal to this. Individuals should be able to decide quite a lot in themselves what a good life is, but it has to somehow remain within the planetary boundaries. And we have to learn how to be liberal, to be free within these planetary boundaries. And that's what we do not yet know how to really achieve. What I think is always important in the context of organic and biodynamic agriculture is the role of naturalness in all this. And this links, so do we have to feed ourselves in a natural way, whatever this means, or is there potential for vertical farming, for example, for laboratory meat and such things? And this links back to the last thing. I think a big question is how to reach those who are not interested in food, who are not interested in agriculture, not in sustainability, and not in climate change. And my claim would be that quite a decent share of the population is not interested in this. And my liberal statement would be they also do not need to be interested in this to live a good life. But nevertheless, as societies, we somehow have to get those on board. And I think it's important to really also make this step to not only talk to the ones that already know what the problems are and basically agree with us what are the solutions, but to really get those on board who are not interested in food, in agriculture, and sustainability and climate change. Thank you.
So from there I will continue, and as we have seen that we really need a larger perspective than just the agriculture system. So we need to include the whole food system in our picture. And we have seen that, that we need to tackle several problems at the same time. So we need really a clear, drastic, and a fast reduction of greenhouse gas emissions. We need to adapt our systems, our farming systems, our society systems, and we really need to stop any practices that are harmful and non-beneficial for our environment, our economy, and our society. As Adrian said, one of the possibilities is to promote organic and biodynamic farming, to do that together, to reduce greenhouse gas emissions, adapt to climate change, and have the co-benefits of organic and biodynamic farming systems that reduce the negative implications of modern agriculture production systems. And for us as farmers, this means that a lot of the solutions exist, and with the biodynamic farming systems, we are already helping to reduce greenhouse gas emissions. Nevertheless, you can still change some elements on your farm to reduce the emissions further. And we did a study within the framework of the Solmark project, where we really looked at different measures that you can take on your farm to reduce them, and among them are to optimize the nutrient management, so like composting or mobile livestock systems, or to optimize your crop rotation system so that you, for example, have a different drying system, or that you use varieties that are more adapted to the local climate. And also to include more forage and grain legumes, because they can increase the nitrogen concentration and nitrogen harvest. And also you can look at your tillage system, so you can reduce the frequency, you can use different machinery for that, and plant agroforestry systems with landscapes elements such as hedges, where you bind carbon from the atmosphere. Of course, you can also go into the direction of using alternative energy sources, renewables, or you can even go to dual purpose breeds. So I would like to emphasize that a lot of solutions are already existing, and this raises the meta question why we as a society are currently not utilizing these farming techniques that we know are good for the environment, our economy, and our society. And we've heard from Adrian that several steps are needed to achieve this holistic agriculture and food system. And one of the central players here are the farmers themselves. So we know solutions exist, and still it needs the individual farmer or the individual consumer that brings this knowledge into an action to really go further and to really outgrow this challenging situation of climate change. I would consider myself as still a young person, although I've learned most of my life lessons, how to deal and move through challenges, how to motivate myself for a greater cause from farmers throughout the world. I had the chance to speak to them, to listen to them, to their beautiful insights of nature and society. And from what I've learned from those farmers, also within the Living Farms project, their insights can be applied to every person of this conference, every person outside of this room here, despite if you're a farmer or if you're just an individual consumer. And I would like to share some of these insights with you to maybe motivate you to overcome the challenges that we are currently facing. So one of the things I learned from farmers is to first take the time to really watch your landscape, your farm, you as a person. What do you see? Did it change over time? And if you love it, stick to it. If it doesn't fit you anymore, change it. And if you can't change it, leave it and let it go. On an individual basis, this may mean that you need to adapt your crop rotation system because it doesn't fit your soil structures anymore, or that your personal values does not fit anymore to your organizational structures and you need to adapt them. This means as a human society, we have always the possibility to adapt our systems, our life, our farming decisions, our organizational structures according to our needs as an individual, but also to the needs of our surrounding, our environment. The second thing I've learned from farmers is, as farmers, we are often pioneers. We continuously have to develop further, and sometimes we have to move out of our own comfort zone to achieve a change. This may be to communicate with people outside of our own areas, and in the worst case, this can mean that other people who have a different perspective help you to sharpen your own goals, and in the best case, this may mean that you get inspired to change something in your system. And that comes along with the third lesson I've learned from farmers, is that some of the most effective techniques and changes come from a very open mindset to really test out of a curiosity new things For example, you can see here in the picture a group of 5,000 smallholder farmers in Kenya that really wanted to try biodynamics. And they went into this approach of saying, oh, I'm just very curious how biodynamics will result with the macadamia harvest. And now they're implementing this together, but really with the perspective of enjoying it, of testing it maybe like a child out of their curiosity. The fourth is to be brave. Sometimes, I think in the climate debate, we have to be brave because we have to decide for changes that are very uncommon for the rest of our society. But if you look at your farm and it makes sense from this broader perspective that Adrian also talked about, it may make sense to change your system. Biodynamic farmers are often pioneers, and at the beginning they may face extreme resistance from other farmers that don't know this concept and that don't know the effects of biodynamic farming. And the best farmers I've met from the biodynamic agriculture are those that, despite this outside communication, stick to their beliefs, but still test new things in a rationally and economically sound way. So if you do better, just 1% per day, this still means a big change throughout 1 year or 10 years. And one of the ideas I got from an advisor is to say, if I test something small on maybe 10% of my area of the farm, this is an economic, sound way to test new things, but still to develop constantly further as a farm. Fifth, I would like to emphasize to communicate and share your story in a way. Often we as people are too shy to share our successes, or we are too afraid to share our failures. For example, you see the picture from one of the winemakers in Italy, and they created a group where they get together and exchange about the worst wines they produced. Because they say, from this we can learn, and we can maybe inspire other people to learn and to improve their systems as well. And maybe this may also motivate other consumers and may create that shift in our society, that consumers really reflect on the value of the food they're consuming and maybe on their individual values as well. The sixth point is to engage with others. I barely know any successful farmer or person that did not have any support. They have networks, communities around them. And if you farm in a community or in a CSA or build a local transition town, that support of the like-minded people may help you to increase your resilience in many, many dimensions. So it helps you to increase your resilience ecologically, economically, but also from a social perspective. And of course, it's much more fun to do things together, and especially if it's such a challenging theme as climate change. And these are the lessons I've somehow learned with speaking to the farmers on the farm, and I try to adapt them to my everyday life as an individual, as a part of the society, and working in the biodynamic movement. And I'm definitely not saying that they're easily to be adapted. They need a lot of time and effort to go on. But I'm very hopeful that they are definitely worth trying to live in a healthy atmosphere, to live on a healthy farm with people that are healthy around us. And for us as a society as a whole, and as an individual who lives in this amazing world, if we suppose that everyone around us in this room and in the online area and beyond is accepting their own responsibility in this debate, I'm pretty sure that we can change the running system together to be able to breathe again in the post-climate crisis. Coming to an end, I would like to do a small experiment with all of you on the screens. I don't see you, so I hope you're with me. I would like you to get up, gently close your eyes, inhale, think about all the figures and facts we've heard today. Hold your breath. Think about one thing that you would like to change now, where you're standing and that you would like to improve in the next day. Exhale now this thought and take one step to a brighter future. Thank you.
So, thank you so much, the two of you. I hope each one of the participants around the globe took this step into a new reality. You encouraged us. And perhaps I have to say to the audience that it's possible that you raise your questions, put your questions in the chat, and they can come to us and we can deal with them. It's still possible. Please, if possible in English and short, but if you ask questions to the two scientists, you can bring them through the chat and we can bring them here in our exchange. If I got it right, Adrian, perhaps first to go back to you from this overall system view and approach. If ever we can calculate and frame a kind of possible future where perhaps climate is not harmed anymore or perhaps protected in some way, there are three main points. So it's a system approach and it's not a pure agricultural approach. But if I got it right, there are three key points. And the one is organic agriculture. The second is less food waste, so contained in the smaller systems, yeah, that they can be managed. And the third one is less meat in the diet. Is this right?
Yes, or I would frame it a little bit differently.
Please.
If you focus on the climate problem, then the less waste and less animal source food, meat, milk, eggs, are sort of the main steps. And the organic agriculture enters as sort of a system that is not maximized to be climate efficient. It is not, but that is optimized to perform well on a whole range of different indicators. And that's the important thing. Because if we focus on climate change only, then we quite fastly lose out the nitrogen dynamics, the pesticides, the biodiversity, whatever, water use. So we shouldn't only focus on greenhouse gas emissions. And organic agriculture and related systems offer systems that are taking into account a whole lot of ecosystem services we can have from land and livestock, and perform reasonably well on many of them, and sort of deal with the trade-offs that are intrinsic. And we shouldn't go for a system that is maximally performing in one indicator, let's say climate change emissions per kg product, because this always comes with a bad performance on other indicators. So we need systems that perform well on all the indicators, but not necessarily maximal. And reducing food wastage and reducing the animal source food reduces the size of the food system to such an extent that we get the room to produce with systems like organic, where, for example, yields are lower because they're not boosted to maximize yields. And we have to take the steps to get this room for sustainable production systems that then perform well on all indicators, and because the system is smaller, in total also perform as well as we need it to tackle the climate crisis.
Okay. But nevertheless, I hope that what we have actually as biodynamic and organic system or approach or impulse can be adapted also to the climate issue. And what I heard also very strongly in your presentation, and actually now too, is that in some way it's the landscape, let's say, frame which would help most to have sustainable and climate neutral or even climate positive systems. Yeah? And this is what we don't have actually in our politics. Yeah? We have either, let's say, the national level, or we have the level of the farm. So if I think this one step further, we should change in some way how we organize, frame our agricultural policy and how we came to decisions and the implementations of the changes we need. You see it the same?
Yes.
Yeah. So this is a very big issue that we have to change, let's say, how we are organized as society, because actually it's either too broad or too narrow. Okay, let's work on it. When you say, I came to a second issue, I heard that some way seems that yield is in organic biodynamic, let's say, perhaps some ways not where it should be, and one could think that it's a nitrogen issue, yeah? You went a little bit in this direction. But I would say in many places I have seen around the world, when you really implement these systems and you work with them, I mean throughout 10 years, 15 years, 20 years, and you adapt. So often you have not this problem, perhaps you have in the first years. You achieve to have a kind of, let's say, management of the nitrogen issue with others, and this works well. And one point, for example, which can be helpful is plant breeding. We know, for example, from the DOK trial here in Switzerland, that by changing the variety of the wheat, we changed the figures in a very impressive way. Could you confirm this?
Definitely, one can run organic systems really optimally and have similar yields than to conventional, but these statements are about average performance. And if you compare a really well-managed conventional system to a well-managed average organic system, I still guess that the conventional one in the tendency would have higher yields, just simplistically speaking, because they aim for having high yields, yeah. And the organic systems aims for having, besides yields or decent yields, healthy soils, healthy biodiversity, and so on. So I think it's not astonishing, and I think it's important. It's also not interesting to a certain extent, but it's important to make a living that these over services that we produce are also rewarded, because when you only sell your yields, you get more money the more you produce. And I think it's such, on average, I don't think that we really can close this yield gap, but I also don't think it's really needed.
Okay. Perhaps I change a little bit for you, Lin, and we can come back. Now I have some questions from the audience. And one, I will perhaps make the three of them together. The one is how to ask people to change their diet. You can reflect 5 seconds. How, the second one, how can we achieve that the value of nature in society is received as essential? Yeah. And yeah, the third one, it's more general, how to change people's mindset in relationship to the world.
Easy questions.
Easy questions, easy answers. But I mean, your approach with the Living Farms project, yeah? You try there to find key points of changes, and how can they now, from these key points where pioneers, they took this challenge on, yeah? And it's always on one little point of this earth, but it has in it the potential to more than just to be for this little point. And your project is about this.
I think research backs me up here. So as a society, if you reach a critical point of 6 to 7% of our society that does something, so be it being a biodynamic farmer or being a consumer that has a climate-friendly diet, the rest of our society is joining in. So that's one of the good news. As soon as we reach the 6 to 7% of people that are happy to do a climate-friendly and resilient agriculture system or thinking that goes in that direction, the rest will follow. And I've done some research where I asked the majority of farmers what is their hindering factors, why are they not currently implementing climate-friendly practices. And one of the main things they said as a hindering factors for other farmers and for other people in society is that we need a kind of role models. We need people that represent how you can do this and how you can live a healthy, sustainable, economic sound way of living and of farming. And we do this in the Living Farm projects by just showing specific farms and places that are already practicing a very sustainable farming system. And the idea is to motivate others by seeing that this is possible and to enable them by this to go into the action of the future. And yeah, I'm quite hopeful that once we've reached this 6 to 7%, that we will look into a brighter future. And of course, combined with the political changes that may come across that way, we will go into a more happier, healthier atmosphere and living.
Okay. The question, how to ask people to change their diet, I mean, you have to offer them the new food where they are. And for example, Demeter did this change in the last years. It went out of the farm shops and of the pure organic shops to the big retailers. So actually, we have, for example, in Switzerland, Demeter products and organic for longer time in the big retail shops, let's say in the supermarkets. Is this the way to go?
I think that's something that needs to be decided on the farmer's level and on the consumer's level individually. So I think as consumers it's great to have the access throughout the world to biodynamic food for sure. And still I also like the way where consumers can come to the farm and take their products directly from the farm, as it is in the case of a CSA model, or to really also experience how much value how much effort is spent to produce, let's say, one bread or to produce one cucumber. It's not just an easy task to do this, and I think for us as consumers it's so important to really again understand the value of food that is produced in a sustainable way. So I think it has to go both ways.
Diversity.
Diversity.
I have one question which I bring to you, perhaps, Adrian. Is there an example of where a landscape perspective has been realized?
Yeah, I guess, or like in regulations, or in Switzerland, for example, in the Seeland, the Sempacher See, Hallwiler See, Waldecker See, there it's clear that the nutrient surplus problem is a landscape problem because the watershed sort of collects all the nutrients and brings them to the lake. Yeah. And there it's clear that one has to tackle it on this level. Or so there are examples, but maybe less really in the basic agricultural policy is not yet set up like this in general. Yeah. Or there are also approaches. It's often linked to watersheds, for example, that you have water pollution at a certain point, and then you see, well, we have to manage the whole watershed to solve the problem. Yeah.
And I may add, like, I think in the framework of the IUCN program in Great Britain, they implemented a system where they really planned the whole biodiversity and agriculture systems for the whole country in a way that you have buffer zones and different core zones of agriculture activities. So that's also one application existing.
Yeah, so it constructs this around problem zones, let's say. Or another example we know from the Sikkim state, which is one little state in the Indian country, where they took decision to have full organic for all agriculture. Yeah? So it has to come out of a kind of regional will and implementation. Yeah. So, shortly said, think global, act local. Thank you so much. Thank you for your contribution.